So here's a very cool problem. Use the method of washers to find the volume of the solid created when the region bounded by y equals x squared, a parabola, y equals 4, a horizontal line, and x equals 0 is rotated or revolved about the x-axis. Also use geometry and the disk method and compare answers. Probably wondering what that's all about. Well, here's what it's all about. Y equals x squared is this parabola. Y equals 4 is this horizontal line, so we want to take this sort of light blue region here and imagine revolving that about the x-axis. So the volume I'm finding is kind of like this light blue region, and eliminating this tornado-shaped, sideways tornado-shaped region. That's not part of what I'm finding. So we can use the geometry and the disk method to do this as well, but let's do it first of all just using the method of washers, okay? Volume would be pi times the outer disk. The radius is 4, so 4 squared. The inner disk, the radius is x squared, so x squared squared, x to the 4th. And the thickness of the disk is what the dx in the integral represents. So without going, we only have to go through the Sally process for this one, I think, to come up with our formula. This is the outer, this is the inner function, and of course you know where the pi came from, and it's on the interval from 0 to 2. Why do I know that? Because the upper border y equals 4 would happen when x equals 2. So that's why I knew that the integral goes from 0 to 2. That's something you have to be careful of. Sometimes finding limits of integration is the hardest part of these problems. So, back to our problem. Integrating 16, we get 16x. Integrating x to the 4th, we get x to the 5th over 5. Pi is a constant out in front of that mess. Put in 0, the whole thing disappears, so we just put in 2 and worry about what we get then. So it's pi times 32 minus 32 fifths. Well, 32 is 160 fifths, so 160 minus 32 fifths is 128 fifths, so it's 128 fifths times pi. That's the volume of that piece. Okay. Now we could also do the volume of the outer by geometry, less the volume of the inner by disks. The volume of the outer is pi r squared h. So pi times 4 squared times 2. Multiplying that out, that's 32 pi. The area of the inner part by disks, that's the area of this sideways shaped tornado funnel, is 0 to 2, integral of x squared squared pi r squared h, pi r squared h. And so we get 32 pi minus 32 pi over 5, and again we get 128 pi over 5. So there we did it slightly different way using geometry and method of disks. So you can see we got the same result with disks or washers.